What's going on, great human? I've got something to show you, and that is none other than my AI math solver. Basically, I got the idea of this project from the Harvard CSFT Introduction to Artificial Intelligence with Python course, and in one of the modules, they taught us about search algorithms. This project is nothing but the manifestation of what my small brain managed to extract from that course, how the mazes looks like and how the project works. So this is the maze and it is fed to the project and the project checks out, where is the starting point, where is the ending goal, and what are the paths that we can navigate through in order to make our way from the starting point to the goal. And all this is done by the algorithm. The algorithm searches through the maze with the help of the rules and techniques given to it. And we also have two other mazes, and we're going to test our search algorithm with all three of them. But before that, let's check out the algorithm itself. If you guys thought for even a minute second that I would make you go through the entire code itself, then trust me, I'm not that bad of a human, because I will only make you go through the structure of the code, not the code itself. And it all begins with a frontier node, which is a list or array which will contain a node. A node is basically a single unit of our maze, and it has many attributes: coordinate, which will have values like this: 13, 2, 13 being the x-axis, 2 being the y-axis, and character, which will resemble the character that is currently being looked at the unit. So it's S because we're starting off, and because we're starting off, the parent will be none, because a parent is basically the node which resulted into the current node, and a starting node isn't resulted by any node, it's just there, we've begun from there. And likewise from the action is basically the step that we took in order to formulate the node, and there is no step taken to get the node. We've basically searched it up and stored it in the frontier node, so basically it's the starting point. The next thing that we will do is extract the node and then compare if its character is equals to G, which in this case is not, G being the final goal. We're seeing that if the current node is the end goal, and if it's not, which obviously in this case isn't, we will go through this chunk of code. Now it all looks overwhelming, but trust me, it is simple as daylight. The center node is basically the current node that we were looking at, and now if it didn't meet our end goal, we will look at the units around it to get a path that will lead towards the end goal. And in this case, I am going to the top. D resembles the top action, and this is our parent 13, 2, which is the current node apparently, and the hash resembling the blockage. So this isn't of any help for us. We will look at the node at the right. So basically it is also a hash, so it serves no purpose. And at the bottom we can also see there's a hash, so we'll just ignore it. And on the left we can see that there is an empty space, and an empty space indicates that we can go there and then eventually find a goal. So this node will be inserted into the frontier node again, and the whole process repeats until we get a character which is equals to G, meaning that we have searched our way, we have looped our way towards the end goal. And if it's the end goal, then we will simply trace back to the starting point using the parents and storing the nodes that come along in a list. And then using that list, we will form a solution and create a solution file and insert the solution there. Alright then, so I'm going to try it first on the maze one. You can see that it looks something like that. And I would open the terminal and I would write this command, which reads python search.py -m to indicate that an upcoming text file is being written, which is maze-1.txt. And if I click enter, it will process it and give us a prompt that the solution is produced in solution1.txt. Now let's check it out. And yeah, we can see that this new file contains the exact path that we would need from S to G, and it is being expressed with the help of the plus sign. So if we follow the plus signs, we will eventually find our way to G.
Pretty cool, huh? Now let's check for the other two, for they are much more harder than the current first maze. Okay, so the second one, I will write somewhat similar command, but instead of maze 1, I will write maze 2. Click enter, same thing will happen, but for solution 2. And if I opened it, we can see that a solution is being formed. And this one was pretty long, but the computer managed to solve it in a second. Now let's see for the final one. And the final one looks just as same. And boom, the solution 3 is also created, which is the path from S to G. Now as you can clearly see that the code isn't optimized, but that doesn't seem as a problem right now because the program executed the files real quick. But for a larger maze, for a much sophisticated complex maze, it would be as slow as your grandma in skateboards. So we have to make it optimized. But making it optimized is a whole world on its own. So we're going to look into that in the upcoming weeks, so stay tuned for that. Besides, I have many projects up in my head, so you will be also expecting that in the coming days. And with best wishes, I'm going to leave. Peace out.